Data and signals are two of the basic building blocks of any computer network. It's important to understand the term data and signal do not mean the same thing, and in order for a computer network to transmit data, the data must first be converted into a proper signal. The one thing data and signals have in common is that both can be in either analog or digital forms. Analog to analog, amplitude modulation, frequency modulation, radio wave, TV tuner, telephone AM and FM radio, broadcast TV, cable TV, digital to digital, NRZ, Manchester differential, Manchester bipolar, AMI, 4B, 5B digital encoder, local area networks, telephone systems. Digital to analog, amplitude shift keying, frequency shift keying, phase shift keying modem, diode learner, access DSL cable modem, digital broadcast TV, analog to digital, periscope modulation, delta modulation, analog to digital, periscope modulation, delta modulation, codecs, telephone system, music system. Data is entities that convey meaning within a computer or computer system. A computer file names and address stored on a hard disk drive. The bits are individual elements of a movie stored on a DVD. The binary ones and zeros of music stored on CD. The dots of a photograph that has been digitized by digital camera and stored on memory stick. The digits 0 through 9. Signals are the electromagnetic impulse used to encode and transmit data. A transmission of telephone conversation over telephone line, live television news interview, transmission of a term paper over printer cable between computer and printer, the downloading of a web page. Analog data and analog signals are represented as continuous waveforms that can be at an infinite number of points between some given minimum and maximum. These minimum and maximum values represent as voltage. One of the primary shortcomings of analog data and analog signals is how difficult it is to separate noise from the original waveform. Noise is unwanted electrical or electromagnetic energy that degrades the quality of signals and data. Digital data and digital signals are composed of a discrete or fixed number of values rather than a continuous or infinite number of values. The first type of digital signals is fairly straightforward and takes the shape of what is called square wave. These square waves are relatively simple patterns of high and low voltage. The second form of digital signal involves more complex combinations of modulator analog signals. When you combine analog noise with a digital waveform, it is fairly easy to separate the original digital waveform from the noise. When you combine analog noise with a digital waveform, it is fairly easy to separate the original digital waveform from the noise. Separate the original digital waveform from the noise. If the amount of noise remains small enough that the original digital waveform can still be interpreted, then the noise can be filtered out, leaving the original waveform. However, the noise becomes so great it's no longer possible to distinguish high to low. The ability to separate noise from digital waveform is one of the greatest strengths of digital systems. When data is transmitted as signal, the signal will always encode some level of noise. In the case of digital signals, however, it is relatively simple to pass the noisy digital signals through a filtering device that removes a significant amount of noise and leaves the original digital device intact. Despite this strong advantage that the digital has over analog, not all systems use digital signals to transmit data. One possible reason is that electronic equipment used to transmit a signal through a wire over the airwave usually dictates the type of signals the wire can transmit. Electronic equipment used to transmit a signal through a wire. Certain electronic equipment is capable of supporting only analog signals, while others can support only digital signal. Consider broadcast radio originally and still is predominantly analog. To change from analog to digital will require radio stations switching to digital transmission system and all users switching to digital radio receiver. The industry is still pretty nominally analog. Three basic components of signals: amplitude, frequency, phase. The amplitude of a signal is the height of the wave above or below given the reference point. The height often denotes the voltage level of the signal measuring volts, but denote the current level of the signal measuring amps or power level of signal measuring watts. The amplitude of a signal can be expressed as volts, amps, or watt. The frequency of a signal is the number of times a signal makes a complete cycle within a given time frame. The length or time interval of one cycle is called its period. The period can be calculated. The length of one cycle is called its period. The period can be calculated by taking the reciprocal of the frequency 1 divided by frequency. The period can be calculated by taking the reciprocal of the frequency 1 divided by frequency. Take the reciprocal. If the range of frequencies that a signal spans from minimum to maximum is called a spectrum. A spectrum of our the bandwidth for a signal is the absolute value of the difference between the lowest and highest frequency. The range of frequencies that a signal spans from minimum to maximum is called spectrum. The phase of a signal is the position of the waveform relative to a given moment of time or relative to time zero. The position of the waveform. Phase is position of the waveform relative to a given moment of time or relative to time zero. Phase of a signal is the position of waveform relative to a given moment of time or to time zero. When traveling through any type of medium, a signal always experiences some loss of its power due to friction. This loss of power is called, or signal strength is called attenuation. Attenuation in a medium like copper wire is the logarithmic loss and is a function of distance and the resistance within the wire. Knowing the amount of attenuation in a signal allows you to determine the signal strength. Decibel is a relative measure of signal loss or gain and is used to measure logarithmic loss or gain. Amplification is the opposite of attenuation. When a signal is amplified by an amplifier, the signal gains in decibel. And there transmitting analog data with analog signals. The basic operation performed is modulation. Modulation is the process of sending data over a signal by varying its amplitude, frequency, or phase. Landline telephones, AM radio, FM radio, and broadcast television are most common examples of analog data to analog signal conversion. To convey this analog data, the station uses a carrier wave signal. In the modulation process, the original audio waveform and the carrier wave are essentially added together to produce the third waveform. Note how the dotted lines superimposed over the third waveform follow the same outline as original. Here the original audio data has been modulated onto a particular carrier frequency, the frequency at which you set the dial to tune in a station using amplitude modulation, hence the name AM radio. Frequency modulation also can be used in similar ways to modulate analog data onto an analog signal and use a FM radio to transmit digital data using square wave digital signals. The ones and zeros of the digital data must be converted to the proper physical form. To transmit digital data using square wave digital signal, ones and zeros of the digital data must be converted to the proper physical form that can be transmitted over a wire or an airwave. If you wish to transmit data value of 1, you can do this by transmitting a positive voltage on the medium. If you wish to 0, you can transmit a 0 voltage. The non-return to zero level allows that L digital encoding scheme transmit 1 as zero voltage and 0 as positive voltage. The LZL encoding scheme is simple to generate and inexpensive to implement in hardware. The square is very square-like. Their second digital encoding scheme is non-return to zero inverter, NRZI. This encoding scheme has a voltage change at the beginning of a 1 and no voltage change at the beginning of a 0. A fundamental difference as this is with NRZI, the receiver must check whether there is a change at the beginning of the bit to determine if it is 0 or 1. An inherent problem with NRZL and NRZI is the long sequence of zeros in the data produces a signal that never changes. The receiver looks for signal changes so that it can synchronize its reading of the data with the actual data pattern. The Manchester class of digital encoding schemes ensure that each bit has some type of signal change and thus solve the synchronization problem. To transmit a 1, the signal change from low to high in the middle of the interval, and to transmit a 0, the signal change from high to low in the middle of the interval. Note that transition is always in the middle. 1 is a low to high transition and a 0 is a high to low transition. Thus, if the signal is currently low and the next bit to transmit is a 0, the signal must move from low to high at the beginning of the interval so that it can do the high to low transition in the middle. Manchester encoding is used in lower speed local area networks for transmitting digital data over local area network cable. The differential Manchester digital encoding scheme was used in a now extinct form of local area network token ring but still exists in a number of unique applications, similar to the Manchester scheme that there is always a transition in the middle of the interval. But unlike it, the direction of this transition in the middle does not differentiate between a 0 or the direction of this transition in the middle does not differentiate between a 0 or 1. Instead, if there is a transition at the beginning of the interval, then a 0 is being transmitted. If there is no transition at the beginning of the interval, then a 1 is being transmitted. Because the receiver must watch the beginning of the interval to determine the value of the bit. The receiver must watch the beginning of the interval to determine the value. The differential Manchester is similar to the NRZI scheme. For the NRZI, it's also transmit 1 as 0 voltage and 0 as positive voltage. The bipolar AMI encoding scheme is unique among all the encoding schemes in TARSVA because it uses 3 voltage levels. When the device transmits a binary 0, a 0 voltage is transmitted. When the device transmits a binary 1, either positive or negative voltage transmitted. Which of these is transmitted depends on the binary 1 value that was last transmitted. The bipolar scheme disadvantage. First, we have the long string of 0 synchronization problem with the NRZ scheme same. Second, the hardware must now be capable of generating and recognizing negative voltage as well as positive voltage. The technique of converting digital data to analog signal is also an example of modulation. Firstly, amplitude shift keying, and secondly, quadrature amplitude modulation. Amplitude shift keying is not restricted to 2 possible amplitude levels. We can create an amplitude shift keying technique that incorporates 4 different amplitude levels. Each of the 4 different amplitude levels will represent 2 bits. Like 2 bits 0 for possible combination 0, 0, 0, 1, 1, 0, 1, 1. Thus, every time the signal change, every time the amplitude changes, 2 bits are transmitted. Every time the signal changes, 2 bits are transmitted. As a result, the data rate is twice the baud rate. A system that transmits 2 bits per signal change is more efficient than one that requires 2 signal change for every bit. A system that transmits 2 bits per signal change is more efficient than one that requires 2 signal change for every bit. Amplitude shift key witness 1 is susceptible to sudden noise impulse like the static charges created by a lightning storm. When a signal is disrupted by a large static discharge, the signal experiences significant increase in amplitude. Second, it is difficult to accurately distinguish among more than just a few amplitude levels. Third, it is the least efficient encoding technique. And fourth, it's not used on systems that require a high data transmission rate. Frequency shift keying uses two different frequency ranges to represent data values of 0 and 1. The lower frequency signal represents a 1 and the higher frequency signal represents a 0. During each bit period, the frequency of the signal is constant. Unlike amplitude shift keying, frequency shift keying does not have a problem with sudden noise spikes that can cause loss of data. But the disadvantage is firstly intermodulation distortion, a phenomenon that occurs when the frequency of two or more signals meet together and create new frequencies. Second, like amplitude shift keying, it is not used on systems that require high data rate. Phase shift keying represents 0 and 1s by different changes in the phase of a waveform. For example, 0 could be no phase change, while 1 could be a phase change of 180 degrees. Phase change firstly, phase change are not affected by amplitude change, nor are they affected by intermodulation distortion. Second, it is less susceptible to noise. And third, it can be used at higher frequencies. Fourth, it's so accurate. Fifth, the transmitter can increase efficiency by introducing multiple phase shift angles. It's so accurate that the signal transmitter can increase efficiency by introducing multiple phase shift angles. It's often necessary to transmit analog data over digital medium. For example, many scientific laboratories have testing equipment that generate test results as analog data. Analog data is converted to digital signal so that the original data can be transmitted through a computer system and eventually stored in memory or on a magnetic disk. Analog convert to digital signals, so that the analog converter to digital signals so that the original data can be transmitted through a computer system and eventually stored in memory or a magnetic disk. Firstly, passcode modulation converts analog data to digital signals. Passcode modulation. Hardware, specifically a codec, converts the analog data to a digital signal by tracking the analog waveform and taking snapshots of the analog data phase interval. Taking a snapshot involves calculating the height or voltage of the analog waveform above a given threshold. Second method, delta modulation. A codec tracks the incoming analog data by assessing our delta steps. During each time period, the codec determines whether the waveform has risen 1 delta step or dropped 1 delta step. If the waveform rises 1 delta step, a 1 is transmitted. If it drops 1 delta step, 0 is transmitted. With this encoding technique, only 1 bit per sample is generated. If waveform rises 1 delta step, a 1 is transmitted. If a waveform drops 1 delta step, a 0 is transmitted. One of the most common forms of data transmitted between a transmitter and receiver is attached data. To distinguish one character from another, each character is represented by a unique binary pattern of 1s and 0. The set of all attached character symbols and the corresponding binary pattern is called data code. ABCDRC, ASCII, and Unicode. The Extended Binary Code Decimal Interchange code (EBCDIC) is an 8-bit code allowing 256 possible combinations of texture symbols. These 256 combinations of texture symbols include all uppercase and lowercase digits 0 to 9, large number of special symbols and punctuation marks. The control character like line, fig, and courage return provide control between a processor and an input-output device. American Standard Code for Information Interchange (ASCII) is a government standard in the United States and is one of the most widely used data codes in the world. It exists in few different forms, including a 7-bit version that allows for 1 to 8 possible combinations of texture symbols representing uppercase and lowercase letters, the digits 0 to 9, special case symbols, and control character. One of the major problems with both ABCDIC and ASCII is that they cannot represent symbols other than those found in the English language. Firstly, they cannot represent symbols other than those found in English language. Second, they cannot even represent all different types of symbols in the English language, like many of the technical symbols used in engineering and mathematics. Unicode is an encoding technique that provides a unique coding value for every character in every language, no matter what the platform. Unicode supports more than 110 different code chats. Spread spectrum technology is a secure encoding technique that uses multiple frequencies or codes to transmit data. Frequency hopping spread, a direct sequence spread spectrum. Direct sequence spread spectrum, this technology replaces each binary 0 and binary 1 with a unique pattern or sequence of 1s and 0. One transmitter may transmit the sequence 1 0 0 something for each binary 1 and another sequence for each binary 0. Another transmitter may transmit the different sequence code. So data and signals are the two basic building blocks of computer networks or data transmitter. Over any communication medium is either digital or analog. Data transmitter with signal that like data can be either digital or analog. Data is transmitter with signal like data can be either digital or analog. The most important difference between analog and digital and signal is that it's easier to remove noise from digital and data than analog. Our signals consist of amplitude, frequency, phase, two important factors affecting the transfer signal, but medium noise and attenuation. Because both data and signals can be either digital or analog. For basics, so analog convert to analog, digital to square wave, digital signal, digital to analog, analog to digital. To transmit analog data over analog signal, the analog waveform of the data combined with another analog waveform in the process known as modulation. Digital data carried by square wave digital signals represented by digital encoding format. Including Manchester encoding scheme, Manchester codes always have a transition in the middle of bit which allows the receiver to synchronize itself with the incoming signal for digital data to be transmitted using discrete analog signal. Digital data must first undergo a process called shift keying, like amplitude, frequency, and phase. And two common techniques for converting analog is carry over digital signals are passcode modulation and delta modulation. Passcode converts symbols of the analog data to multiple bit digital value. Delta modulation tries analog data transmit only a 1 or 0 depending on whether the data rises. Delta modulation tries analog data and transmit only a 1 or 0 depending on whether the data rises or falls within the next time period. Data codes necessary to transmit letter, number, symbol, control character. Two important ASCII are EBCDIC Unicode. EBCDIC use 8-bit code and allows for 256 different letter digits. IBM mainframe used the EBCDIC. ASCII use 7-bit code and allows for 128 different letters. ASCII is the most popular data code in the United States. Unicode is a 16-bit code that supports more than 110 different languages and symbols all over from the world.